Hello. Today we'll discuss one of the example where actually we apply the semaphores algorithm. This is actually called the reader writer problem, and it is this problem we are actually using with the semaphores. Okay. So what is this problem? This problem actually can be seen in databases. In databases, there is a problem of reader writer where we can see it. This is not like only in databases. We can get this problem even in file systems. Whenever there is a problem or reader writer, there we will get it. So whenever this kind of problem encounter, just remember the concept and change some code according to requirement. So these problems we are using. This is an practical example of the semaphores in the real world problem in the semaphores. But this problem might be in various situation. Might be you are a database engineer, then you can get the reader writer problem. Might be you are actually going to make efficient in the file system. The file system actually have lots of user which who all are using the reader writer problem. You are also facing these reader writer problems. There also you can get this. You can solve by this solution. So what is actually situation? The situation is, suppose there is a database, and this is actually database table. As an operating system, I can see it as a database table. So this database table has a database table. Okay, this database table is accessed by the reader. This might be accessed by the writer. Reader means, suppose there is some SQL command like select. The select means we are reading something. Writer, writing something like changing the table, or changing the tables. Changing the table. It's actually admin purpose. So they are changing the table, or they are writing something in the table. They are writing something in the table. Okay, writing some rows, changing some rows, like that. So these two things can happen. Suppose there is some user 1, user 2, user 3 in the reader side, and writer side user 4 and user 5. Okay, then what is happening? These readers can access these databases simultaneously, but the writers cannot access this in simultaneously. Suppose user 1 can read something, user 2 read something, user 3 read something. That is fine. But when the writer is going to write, the user 4 and user 5 is the writer. They cannot do this simultaneously because writing will be overlapped, and that will create a problem. But in the reader side, the reading can be done by more than 2 or 3 or 4. Okay, that is not a problem. And also another issue, two issue I have discussed. First issue is the readers. If I am just telling about the readers, the readers can access, means readers can read simultaneously 2 or 3 or 4 or 5. More than one reader can read something from this database page, database table. And this is one section. Second is, when we are using the writers, the writer cannot do, because it will overlap, and it can overlap the writing, and it can create the problems. This is the second. Third is, the when any reader is reading something, writer cannot access this database. Either they are reading something, then writer is writing something. Okay, then whatever the reader have read, that might be as expected. So this is the another problem. Now, the note it, when some process is writing in databases, no reader process should be allowed to read. Whatever I have discussed. There can be multiple readers reading simultaneously. Fine. But while a reader is reading, a writer cannot start writing. When a reader is reading, when a reader is reading, a writer cannot start writing. Obviously that will be mess up. The writer has to wait for the readers to finish the task. Writer has to wait the that's one. This is very important terms. This uh, press this point, the writer has to wait for the readers to finish the task at first. And there might be multiple cases for these reader writer problems. First case is, suppose there is one reader and one writer. Suppose this is actually case, one reader and one writer. In this side only one reader, in this side only one writer. What we can do? We can just have a binary semaphore which controls access to the critical section. We can get, so how we can actually solve this problem? The reader writer, because might be writing something, the reader can reading something and it can get overlapped and mess up this all the situation. So how can I solve this problem? By this code. What is the code? Entry down B. Now we know that what is the binary semaphores. Binary semaphores, counting semaphores, we know. So we are most probably we are using here the counting process. The whole problem statements, in whole problem statement, in the redirected problem, we will just use the binary semaphores, right? So here for the one reader and one writer, just what we will do, we have the entry point and the exit point. In the entry point we will down the binary semaphores, means it is getting blocked to entry any kinds of the reader or writer to its critical section. So then after that critical section will go up and critical section will go, and after finish this critical section, we will relinquish the control for this particular writer, and then the reader can, if reader was wishing to read something and was blocked due to this writer, then it can read or fine. So this is actually problems. So this might be for the reader problem or the writer problem. It is very easy. Next case 2 might be, that is the n readers and one writer. Suppose there is an more than one reader and there is an only one writer. Then what is the situation? You can very easily see here that if it is one writer, then when any of the n readers are in critical section, then a writer cannot go in the critical section. But any of the readers, simultaneously two or three readers can go in the critical section. This is actually solved. This is actually our problem. Okay. Case 3 is the end readers and right end. That is actually our point to observe. That if there is a lots more readers, there is a lots more writer, then how can you solve this problem? One writer, if there is one writer, then this is okay. When one of the writer is fine, we can control somehow. But when there is an end reader and item, that is actually a problem. That is actually question. Okay. In general, what I have written, in general, end readers can go in the critical sections. In general, end readers can go in the critical section. Means all the readers is permitted to go to the critical section. But if any of the readers are in critical section, no writer can go into the critical section. The same way, vice versa also, if any of the writers is in the critical section, then no readers can go its critical section. And one thing, that if any one of the writers are in the critical section, no other writers can go in the critical section. That actually differentiate, you have to understand from your own. Fine. Now how the code is work? Code is very simple. We have writer problem, we have the reader. We have the writer, here is the writer's code, is the reader code. It is same like producer consumer problems, where we have had like producers here, we had like consumer here. And this is actually basically the reader's code. Okay. Here is the producer, but producer computer problem, what was that? That when one producer was produces something, no other producer can produce something, and also the consumer as well. The same thing also one was that when one consumer was consuming something, no other consumer can consume. But here this is completely different, not exactly like producer consumer, but it is somehow the like the producer consumer. Here is the same, that when a reader can reading something, but two or three readers can go in the simultaneously in the critical section. This is actually can make the differentiate from the producer consumer problem. Then only it is fine. So how we are doing for the writer, we can get very easy code that while true entry point is down RW, then you can go to this critical section. The write db means we are writing something in database, then exit point of rw. Now what is rw? This is actual point. So this is actually, first understand this, that this is actually our shared memory. In this shared memory, there is an one variable rc that is equals to 0. There is binary semaphores, b semaphores actually given the terms b semaphores, rc equals to 1 and b semaphores rw equals to 1. These three variables we have initialized in the shared memory. Now what these terms implied for? What these terms work for in this code? Let's see. The RC is basically the readers count. The RC is basically the readers count. It will count that how many readers are there. How many readers are there in the critical section, or how many readers are reading something, in other words. Second is the MRC. MRC is basically it can mutex the RC. So mutex to access the RC. It is actually the mutex to access the RC. Mutex to access RC or mutex to control the RC. Anytime you can mention here. To access RC. To access RC means whenever the readers reading something, then what is this? Whenever a readers is uh, reading something, then they have to increase this variable. They have to increase this variable. RC equals to RC plus 1. So whenever they are increasing, whenever a reader is increasing, some other reader should not increase it. How can I control it? I can control it by the MRC. Second, this is the RW. This is actually mutual exclusion between readers and writers. It is actually the variable. RW is basically the variables. This is also binary semaphores. To control, it is actually basically the control the between the readers and writers, or among the writers. Means I have already discussed this. Two or three writers cannot go to this section, but two or three readers can go, or reader writer cannot go. How can I control it? By this variable. Fine. So how this code work? So in the writers problem, I have already discussed the RW is basically a binary semaphores. It is only for controlling the readers or writers, or two or more writers. So this is actually empty down the RW. Whenever we are doing this RW down, it basically makes to 0. Fine. This one go to this 0. 1 goes to this 0, because this is the downing here. We know how the down operations of binary semaphores happen. It actually makes it 0 so that no other process can enter into the critical section. Next is they can enter in the critical section. Okay, because if it was already 0, if it was already 0, then by downing it would make -1, but -1 does not sense and it would go to the sleep mode. But here because it is 1, it makes it 0 by decreasing, so it can very easily go to this critical section. Third thing is, whenever this critical section is going on, the reader cannot go. How reader cannot go? Let's see this example. When the reader is going and encounter these operations like down MRC, whenever a reader is going to now here in the reader in the critical section, now I am discussing about the readers. A writer is the critical section, then I am discussing about the reader. One reader suppose going to this down it, so it will down the MRC is also by semaphore, so it will go to this 0. It is fine to go. RC equals to RC plus 1, it can increase the RC, RC equals to RC plus 1. Now if RC equals to 1, if RC equals to, yes, this is because this is the first reader, so it is RC equals to 1. Obviously RC equals to 1. True. This condition is true. Then it can go to down the RW. Then it is going to down the RW. RW means we know what happened to the RW. It is already 0. So here again I am in contact the down the RW. So 0 becomes -1. 0 becomes the -1. So because it becomes the -1, it immediately go to the sleep mode. It cannot progress actually. It cannot go to this critical section because it is the entry point of the readers and it is the exit point. Middle of this is the critical section. It cannot go to the critical section. So it is going to sleep mode, stuck. After that, whenever it went down, whenever it go it relinquish its critical section, it is actually going to up this RW. Up this RW means RW becomes 0. Up this RW means RW becomes 0. So up this RW means, so up the RW means it is telling that whichever is in sleep mode, you can go to further. So which one is the sleep mode here? The sleep mode is this one. Then only it can go to the further. Whenever it is going to the further, it is going to up this MRC. Already it is RC plus RC equals to RC plus 1. Very easily you can see. So up is MRC. Then it is going to up this MRC. Up this MRC means MRC becomes now 1, right? Means it is telling any others readers you can enter to the critical section, not a big problem. So it can go to this critical section now. Now read B is our critical, so it is in the critical section. Any other reader is trying to enter it. Any other reader is trying to enter it. So any other readers is going to down this. So this is actually down MRC. Whenever it is doing down MRC, down MRC is already 1 we know. So this is becomes 0 and it is going to the increase the RC. Now RC equals to RC plus 2. It is not 1. So if it is not 1, then no need to do again the down operation. Was downing already done, already it is blocked after one operation of router. When the readers was going to go from the sleep mode, it was already blocked. I mean, no other writers can enter into this critical section until or unless all the readers are relinquished from this uh, reader group. Fine now. So this is going to read something critical section. Then it is going to RC equals RC plus 1. Then again the up, it is going to up the MRC. Up the MRC means it is actually going to 1, going to do this 1. Again it is back to this 1. Okay, if it is already 1, then it is going to up to this and it can enter to the critical sum. Now you can see that two things, that two reader is in the critical section. Then again it is going to down this. When one reader is going from his critical section, it will down the MRC. Down the MRC because it has to do this operation. RC equals to RC minus 1 because one reader has already completed. So reader count will be decreased. So reader count will be decreased. So to decrease this, again you have to use the shared memory. So if it is using the shared memory, then I have to make it uniquely. So how can I do this uniquely? By making this MRC down. Means no other readers can process at this moment. So this is actually going to down this. Now if RC equals to 0, RC equals to 0 means suppose they are going to down this and it is going on. And at the last of this process, at the last reader will be RC equals to 0. The last reader when finish its operation, then RC equals to 0. If RC equals to 0, then no reader is found. Then let's the writers do, let's the writer control the critical section. How can I do this? By doing this up RW because the RW was minus 1. RW was 0. Sorry, RW was 0. So it will make it 1. It will make it 1. When the RW was 0, here RW was 0. Now for this operation RW is 1. Fine. So it will up the and then the remaining all the writers can go to this to write this operation. Okay. Then also it is going to up the MRC. Up the MRC means MRC will be up because MRC was down because of this operation. So this is actually exit of the reader. So this is actually entry of the reader and this is actually exit of the reader. In this way the code is working. It's very simple code. If you just see here, see these codes, then you can very easily. The main point is you have to understand this. You have to understand this. that is the end readers and end writer. In general, end readers can go in the critical section, but if any of the readers are in the critical section, no writer can go in the critical section. If any one of the writers are in the critical section, no other writers can go in the critical section. This is the main point you have to observe. If you can understand very easily, then you can very understand easily this code how it is working. So this is actually code and this is actually all. So what is happening, I am discussing again. In reader process, first is before we access or modify RC, we want to get control of RC using the MRC, whatever I have discussed. If RC equals to 1, it is true, then the first reader is has arrived. Because the first reader is arrived, block the writer. If RC equals to 0, then all the readers have finished. That means then it is the last reader. Then do up RW so that writer can get its control, whatever I have discussed. Now, one point you have to note, in the real world, we will encounter lots of example of reader-writer problems, like multiple processes are trying to read or write a file at the same time. The same thing I can give the solution of the same thing by these reader-writer problems. So that was actually to discuss here. Fine. Thank you.